Hello, I am Odune and you are in my land. Today, I want to make an interesting creation for you. In this channel, we are going to make a lot of cool and interesting things together that are difficult for many people. But together, we will make them together in the easiest and simplest way. So I would like to thank you for supporting me and my channel so that we can get value and subscribe to the channel to join us on this path. Let's go do our job. How are you guys? In this video, we are going to talk about binary counters. What are binary numbers? And learn a circuit for counting in binary style or computer language. Yes, computer language. Have you ever heard of the names 0 and 1? I'm sure you have. In fact, when humanity wanted to express a basis for computers, or more simply for data, it came and used 0 and 1. Why 0 and 1? The reason goes back to humans and humanity themselves, because humans have always been stuck between right and wrong. Unfortunately, it is not. The Neilang circle in Eastern Asian culture can be a clear example of this. We humans have always wanted to have logic, and this logic is either right or wrong. Either useful or harmful, either good or bad. You see, even in vocabulary, one word means the opposite of the other. From here, logic entered the world of constructs. That is 0 and 1. In computer language, 0 means error, silence, harm, etc. And 1 means useful, correct, and clear. Later, with the advancement of science, humanity began to build things called logic gates that could further advance this process by integrating mathematics into logic. Humans came a few years ago and built logic gates and logical relationships for 0 and 1. You can see some examples of them. In the figures, you can see the AND, OR, NOT, and XOR gates. Their relationships are also written below them, but we don't want to delve too much into the engineering discussion, so that's enough. Well, we now understand 0 and 1, but we don't know what binary is. In fact, binary is nothing special. Binary is our normal numbers written in a special base of 0 and 1. You can see examples of it. Now imagine that we want to go from 1 to 2 and show it with a circuit. We're going to do this together today. But before that, there are a few more things you need to know. Bold numbers have bases of 2, 2, 4, 4, 8, 8, etc. We are now working with base 2. Which is the most common way of writing binary numbers. First, you need to know what the chip we are using in our circuit today is. That brain is our IC, which has different functions depending on the numbers written in it. This IC, which is the brain of the circuit, has several gates inside its heart. You can find out what bits make this IC beat by just typing its IC number in your browser's search bar. So, let's talk about 0 and 1. How do we have 0 and 1? Look, at the same time that humans came up with the idea of creating 0 and 1 out of boredom or whatever else we think of, they also came up with a definition for creating these logics themselves. I want to tell you simply and easily how these logics are made. I can say that in electronic circuits, 5 volts means 1, and 0 volts means a logical 0. Also, if you are like me, use a pulse that is a cycle of zeros and ones. Where the pulse has a positive peak, it becomes a logical 1, and where it has a negative peak, it becomes a logical 0. If you're as tired of all these explanations as I am, let's go and close our circuit together. They've included a list of the parts you need to assemble this device in the caption. Well, I'll tell you step by step what you need to do. If you're a long-winded person, there's a circuit diagram that's been uploaded to our channel, the link to which I've included below, and you can view the circuit from there. The first thing you need to do is take the IC and, according to the schematic I told you how you can have it, keep in mind its pins. For example, each IC has a hole on it, which for logical ICs is often located on one of the horizontal sides. The bottom row of ICS, that is, the row below the IC, is assigned the numbers 1 to 7. The first pin in the bottom row, which is closest to the hole, is called pin 1, and the one opposite it in the top row, which is pins 8 to 14, is called pin 14. So, we have learned the IC pins. Let's move on to assembling the circuit. First, we place the IC on the breadboard. If you don't have a breadboard, it doesn't matter. You can make the connections using a soldering iron and wire. After that, you will take a wire to connect it. Step 1, you need to make a connection between pin 1 and pin 12 of the IC. Step 2, get your own 5-volt battery or power supply and connect its negative pin to pin 10 of the IC. We will connect the positive pin to pin 5 at the end when the wiring is finished and the circuit is ready. Step 3, you need to connect pin 1 to your logic 0 and 1. You can do this with a pulse generator or the positive side of the battery. We said that. 5 volts is defined as a logical 1 and 0 volts as a logical 0. Step 4. Take your LEDs and connect their negative terminals to the negative side of the battery. Note that a resistor with the value stated in the description must be placed before each bulb. I have not placed them so that the circuit simulation is not cluttered. The first lamp should be connected to pin 12, the second lamp to pin 9, the third lamp to pin 8, and the fourth lamp to pin 11. I mean, the positive pin of the IC that is connected to the resistor. That is, connect the resistor pin to the numbers mentioned. Connect pins 2 and 3 to the negative of the battery. So in the last step, connect the positive to the battery. Now, by connecting the wire that is connected to pin 14 of the IC to the positive of the battery, you can see that our system is counting numbers, but in a computer way. First 1, then 2, then 3, and so on until you see the binary number 1111 in the lamps. I hope you learned a lot from today's video. If you have any questions, ask them in the comments so that they can be answered. I would appreciate it if you would like to support my video with your likes and subscribe to my channel to give me energy and follow me. See you soon. Be like fire.